Simple blockchains are dead. Long live the trees of blockchains. We are building a trust-scalable system powered by a networked set of homogeneous blockchains based on our WasmX engine. This network is a multi-level decentralized hierarchical tree where the tree is constructed in reverse from leaf nodes to root. Our WasmX engine, the core of every chain, is a WebAssembly-based, upgradable and customizable blockchain core that can be extended through WasM modules. It is compatible with both Cosmos and Ethereum blockchains. In fact, WasmX uses the Cosmos base app while re-implementing all additional modules as WasM contracts. WasmX is extensible with different languages, different consensus algorithms, different roles and privileges for contracts, roll-up chains, and something that we will demonstrate in the near future, plugins for sets or groups of nodes. Our MythosX system is a collaboration between Mythos, a private level 0 chain, and our networked subchains that we call levels. All of these blockchains run on WasmX, and today you will see a demo of nodes running MythosX. We now have 3 nodes here, each running the Mythos chain and their own private level 0 chain. They're also running a time chain that we presented in a previous video. And we can see this through the logs. We see logs for Mythos, and we see logs for the level 0 chain. And we can also see the blocks being produced here. And if we look at staking, we can see the 3 nodes here, node 0, node 1, and node 2. And now 2 of these nodes will negotiate and spawn a level 1 chain. The negotiation transactions are recorded on each level 0 chain, so each node has its own negotiation history. And each node sends a Genesis transaction with their validator information to their respective level 0 chain. At the moment, the creation of these levels is programmatic, and before the Genesis transaction, the nodes have already negotiated their Genesis data. And we can see that these 2, node 0 and node 1, have negotiated the Genesis data for a level 1 subchain. So we are going to send the Genesis transaction for node 0. And we can see the transaction was added to the mempool on the level 0 chain. And it has added the Genesis transaction for the level 1 Genesis, and then this node 1, has also received this updated Genesis data. So now we are going to sign the Genesis transaction for node 1 for the subchain, for the level 1 subchain. We have this registered on the level 0 chain, and we can see the Genesis transaction was added, and it has already started to create the level 1 subchain, both nodes. So at this point, node 2 doesn't know about this level 1 subchain. And node 0 and node 1 are initializing it. And we already see the level 1 subchain starting to finalize blocks. So now, if we go to the Explorer, we have opened the level 1 chain that has been initialized. We see it has reached block 4 already, and it has two validators, the validators that we have created. It's Lore and Lore2. So what we want to do now is we need to wait for level 1 to reach at least height 10, because that's when snapshots will be created for this chain, so that we can sync node 2 and make node 2 a validator on this level 1 chain. So what we are going to do now is prepare node 2 to sync the level 1 chain. So we will use node 0 for being an RPC provider. And we can look this port up, and yes, this is the port, the RPC port for the level 1 subchain. We'll keep track of this. So we already have 10 blocks for the level 1 chain. Yeah. What we need to do at this point is register the chain with node 2. So we have here all the information, the chain ID, and we have the bag32 prefixes for addresses and the denominations. And we first run this transaction, and we are working with the level 0 chain. So we are registering the level 1 subchain with the level 0 private chain for node 2. And this transaction has already been processed. So now we are going to get the last trusted height 17 and the hash, and we are working with smart contracts here with WasmX contracts. So we will instruct the level 0 chain of node 2 to start state sync. And this is the contract that will provide the verification for headers, for block headers, for the state sync, because we can have different consensus protocols. And we will need the peer address from node 0. It's actually node 0, but we will use this level 0 address. Okay, the RPC is correct. And now this level 0 address will actually be transformed, converted into a level 1 address automatically. So with this, we already see level 1. The level 1 chain has been initialized. It's trying to connect to the peers. So what happened is that the chain is actually with a 1003 ID here. This is the chain that was negotiated. So we will need to change this here. So we will register the new chain with node 2. And let's get the last block, block 48. And now let's sync this chain. Okay, we have started state sync, discovering snapshots. Discovered already 2 snapshots. As I said before, the negotiation protocol is automatic, and sometimes you don't know exactly what nodes have come to an agreement to start a node, but we will have a notification process. So we already see part of the state sync that headers have been verified, and the snapshot chunk was applied to the ABCI app. And now we should soon be seeing, yeah, this node 2 has connected to the other nodes. It has started to receive additional block proposal for the level 1 subchain. So let's see, the last block is 53. And this is at 56. So now what we are going to do is prepare the transaction for creating a validator. So let's see first with our node 2. We will get our address. We'll update this ID to be 1003. And what we're going to do is convert this address. So we are sending some level 1 tokens for the node 2 address. And we already see the transaction being added to the mempool for level 1. We are going to prepare the validator. Let's see the public key that node 2 has and update our validator create level 1 file. Okay. And now update the chain ID, and we need to also update the memo, which will contain this node ID, but with an updated address for level 1. So looking again at the level 1 chain, now we have only 2 validators. And we will send this transaction to add node 2 as a validator. We can see the transaction has been added to the mempool on level 1 chain. Let's see when it's indexed in the block, and we can see that the transaction was indexed, and immediately afterwards, so it has been indexed at height 76. We can see it has one transaction, and this is the create validator transaction, which was a success. Immediately afterwards, this node determines that it's a new validator for this new level 1 chain, and it starts to connect with the other nodes. And at this point, if we go to staking, we see 3 validators. So this is how on the same node you can run multiple chains. We have Mythos, the level 0 private chain, and now we can start a hierarchy of public chains that are negotiated and created through the level 0 chain. Each chain state is stored in the same database, but it is separated with its own prefix. The state is completely independent. Each chain also can have access to the state of the other subchains. So this opens up the way for very interesting cross-chain transactions, and in previous videos we have already demonstrated that. This multi-chain hierarchical tree-like system is heavily based on our consensusless contracts theory, and we have explained this theory in detail in previous videos. The core protocol is contracts that can be upgraded through governance at any time. The chain negotiation protocol, for example, can be upgraded at any time during the lifespan of the chains. The consensus protocols also. This is the most complex decentralized tree-chain system, a system created for decentralized collaboration and development, created to scale at network state levels.